Ionic and metallic bonding. Section 7.1, Ions. Here's the objectives. Go ahead and put these in your notes. Determine the number of valence electrons in an atom. Explain how the octet rule applies to these metal and non-metallic objects or elements. Describe how cations form and how anions form. Alright, all of the elements in a group on the periodic table are going to behave similarly for one main reason. Because they have the same number of valence electrons. That's the key. Alright, so what's a valence? Well, valence electrons are the electrons in the highest occupied energy level, what we talked about in the last chapter, you know, the outermost electrons. So if we're talking about something like sodium, you know, where sodium's configuration 1s2, 2s2, 2p6, 3s1, anything with a 3, that's the outer configuration. So that's its outer electron, that's its valence electron. Valence electron for that sodium. Alright, here's some electron dot structures. This is a pretty common way that they write these. Rather than writing out all those configurations, which gets a little bit long, especially when you're talking about some of the bigger atoms, they write electron dot structures. And what they do, so like we just did sodium, we said it had one electron in its outer energy level, so we put one dot. Or if we're talking about something like oxygen, oxygen's in group 6A, it has 6 electrons in the outer level. 1, 2, 3, 4, 5, 6. So we would put 6 electrons around it. So that's what they're talking about with the electron. Now, I always have this rule. I always say that 8 is great. Okay, so you can kind of remember that 8 is great. That kind of is what I'm talking about, is the octet rule. A guy named Gilbert Lewis discovered this and found out that atoms try to get to 8 electrons when they form ions, because that's a very stable configuration. So 8 is kind of the magic number for all of these atoms that they're trying to get to. So atoms that are metallic, they usually lose electrons and they go to the lower energy level. So they tend to drop level. If we're talking about non-metallic elements like chlorine or oxygen, they tend to gain electrons and fill their level. Alright, first talk about the cations. And if an atom loses valence electrons, so we've taken away a negative charge, it now becomes positively charged, and that's a cation, remember? So they're positively charged. If we're talking about the name of the ion, now understand that the ion is much different than the element. If we're talking about the name of the ion, for sodium, you know, we have the sodium atom. If we create the ion, it becomes Na+, we've lost that electron, and we simply call it the sodium ion or the sodium cation. So the name stays the same for positive, for cation. Most of these that form are formed from metals. The metals are the ones that lose the electrons. Let's take a look one more time at the configuration. So we got 1s2, 2s2, 2p6, 3s1. We're trying to get to that magic number of 8. Well, the magic number of 8, if you have a full S and P sublevel, that's perfect. So what sodium is saying, hey, if I can get rid of this electron, take that out of there, I now have an outer level that's full, that has 8. It's trying to do. So it has 1 valence electron, so we just put 1 dot by it. That's our electron dot structure for that. Magnesium, it has 2 valence electrons. It's in group 2A. And the group number for the representative elements, for the group A elements, tells you the number of valence electrons. So it's in group A, so we'll put 1 there and 1 there. There's our 2 dots around magnesium. That's its electron structure. Okay, so we just drew. And anything in group 1A, all of the elements in group 1A become plus 1. The elements in group 2A become 2 plus. If you're in group 3A, you become 3 plus. Okay, so here's our examples. Lithium, sodium, potassium, rubidium, those are all going to be plus 1 ions. Beryllium, magnesium, calcium, those are all going to be plus 2 ions. Silver is not it's not a representative element. It's a transition metal, and is one of these that forms what we call a pseudo-noble gas configuration. Pseudo meaning false. It is not a true noble gas. Noble gas configuration would mean it has 8 electrons. Well, the next best thing, if you've got your S sublevel filled, you got 2. If you got P sublevel, you got 6. And that's perfect. That's our noble gas configuration. The next best thing is to also have the D sublevel filled with 10. And rather than having 8 electrons, that's a total of 18. So silver has this pseudo-noble gas configuration where it has 18 electrons in its outer level. And that's a pretty stable configuration for silver. So that's what it tries to do. So can't get it would have to lose way too many to get down to 8. It could lose, it'd have to lose like 11 to get down there. But it gets down to this 18 instead. All right, let's talk about anions. These are the ones that gain electrons. These are the nonmetals that gain electrons, become an anion. These we changed the name of. The names now end in IDEs. It used to be chlorine when it was an atom. When it becomes an ion, gains an electron, becomes Cl minus, now becomes chloride. So if you see this IDE ending, that tells you that you're working with, in most cases, there are some exceptions, but in most cases that tells you that this is going to be a positive or a negative anion. All right, so let's take a look at chlorine. This is its electron dot structure. Oops, give me my dot there. We've got 7 electrons around the outer level. And 7 it doesn't like. So what it does is it tries to find something like sodium, who has 1, and says, hey, give me that electron. I'll take it. Sodium then becomes happy. Chlorine becomes happy. And that's what happens. So when this happens, this becomes the chloride ion. This becomes the sodium ion. So that name doesn't change. It just becomes an ion. But that's how that works. All of the halogens are going to lose 1 electron. I'm sorry, they're going to gain 1 electron. They're going to gain an electron, become -1 charged. Those are known as halides. All of these are examples of nonmetals that gain electrons. Once again, you would change those names to end in IDE. Now, there's some strange ones. So, like nitrogen, nitrogen becomes nitride. We lose all that, the ending part of it. Phosphorus becomes phosphide. Chlorine becomes chloride. Bromine becomes bromide. Those are pretty common, but those and phosphorus different. All right, so let's take a look at sulfur. Sulfur has 6 valence electrons. 1, 2, 3, 4, 5, 6. So it's trying to gain 2 more. So it's going to find somebody who has 2 electrons over here, and it's going to get those. And when it does that, it's going to get its 8, its magic number. But when it does that, it now is going to become a 2 minus charge because it's gotten 2 extra electrons. Deal. All right, aluminum. If we talk about aluminum, by the way, I did not name the sulfur one. That would be called, since it gains electrons, it's going to now become a sulfide ion. Okay, aluminum has 3 valence electrons. So if you're trying to figure out, well, which is it going to do, it could either gain 5 to get to 8, or it can lose these 3. Well, 3 is easier, so if that's what it's going to do, so it's going to lose those 3 electrons. It then becomes an Al3 plus ion. The name of that is simply aluminum. It's the aluminum ion, or aluminum cation. Alright, so it says how many electrons are lost or gained in forming each. So think about this. If I form Ba2+, barium 2+, it becomes the barium ion or the barium cation. How many electrons did it gain or lose? Okay, it lost 2. How about arsenic? First of all, what's going to be its name? This one would become arsenide, and it's going to gain 3. Or if we have copper 2+, well, it's going to lose 2. It would just be called, it's the copper ion, and that's what it is. Alright, so that's the end of section 7.1. Make sure you go back and check out your objectives, kind of jot in a few things about them, so if we need to do anything and talk about that, you've got it. Okay.